Okay, today I'm gonna show you how you can repair a broken buck or boost regulator in any electronics. I have already made a video about this before. In case you haven't watched it, I will leave the link down in the description. So when I first open this speaker, the most obvious fault is this capacitor is what's here. It is clearly exploded in the top, as you can see. This clearly is faulty, so I replaced it with a new one, and it still doesn't work. So of course I found the buck regulator IC. This is the buck regulator inductor. The buck regulator IC was here, and here is the IC. The model number is this EUP 3482A. This is a 2 amp buck regulator, and the thing you need to know is when will it start to work. The most important one is here, the EN enable pin. Look here, it says the enable pin need to be connected to the in. So we need to measure the EN. EN in this instance is here. Let me zoom in a little bit. This is the EN. It go to this capacitor for a delayed startup, and it goes to this resistive divider, and here's the input voltage. This is the other input capacitor. From here, this is 19 volts inputs. As you can see here, 20 volts. It's actually just 18, but it's close enough. The input goes here through resistive divider and to the input pin. So I measured the resistance. Just in case the resistor is broken, I removed the pull down resistor because the datasheet say it's okay to connect to the input directly. So I tried that, it doesn't work. And judging by how the input capacitor exploded, that probably means the chip is also damaged. And in this case, you need to be very careful, because when the capacitor is exploded, that means there is a over voltage event. So there might be because the capacitor is rated at 16 volts, there may be more than this present when the buck regulator is broken. So you need to check all the other circuits survived the over voltage. I have tested it with a bench power supply and everything is still okay. So now we need to start modifying it. The first thing you need to check, actually before you check it, you need to know the output voltage of the buck regulator IC. Most IC uses a feedback pin with a resistive divider, like shown on the typical application. Here you can see here's a feedback pin, here's the output, with the output capacitor, and here is the resistive divider. So the resistive divider value will control the output voltage. Basically, the chip tries to keep the FB at the voltage it will specify here. It says FB is 0.923 volts. So the chip will try to keep the FB at 0.92 volts no matter what. So to control the output voltage, you change the resistive divider value. And the FB is at here, the opposite corner of the dot. Let's look at the real circuits. Here's the dot. So the opposite side is this pin, which I've removed one of the resistor for the divider already because I want to measure it. Later I will show you. The pin connects here. This resistor pulls to ground. This connects to this resistor and another resistor in series. In this case, in most cases, this is just one resistor, but they can't find the proper value, so they put two in series. And here's the output capacitor. Basically, the here's the output capacitor. This is the out, the GND. Here's one resistor, and this one go to FB. And here is two resistors in series, and it goes to out like this. So we need to measure the value here. Value here and here. I have removed this resistor. The resistor is here. It's very tiny. You can probably see it. The resistor is smaller than the probe. Almost flung it away. It's 12.97, almost 13. I'm not making a good connection, but it's 13 ohms. 13 kilo actually, 13 kilo ohms. Then we need to measure the other two resistors in series. One connection goes to the FB pin. You need to disconnect the IC for it to be accurate. The other one connects to the output capacitor. It's 60 kilo. Okay, so with this we can calculate the output voltage. Here's how to calculate it. The FB pin will keep 0.967. The resistor for the output, the lower side resistor is 13 kilo. Upper side is 73 kilo. 60 plus 13 because you want the output voltage, not the voltage on the upper one. So the output voltage is 5.183, so basically 5 volts. Then you can use bench power supply to output this voltage and test it. After you verify it, you can then use any buck regulator module you like. In this case, because this is a more critical application, this is audio, so the noise of the buck module is very critical. I use a MP1584EN. This is best I can get. You can get even better one online, but I just don't wanna wait. You can also use LM, those, yeah, super cheap ones, you already know. We can get $1, you can get 3 of them, but you need to make sure it can handle the current. You can see what current this one is designed for, original one, then get more, it's okay, this is not. Then how to wire it? Need to look at the data sheet again. The typical wiring scheme. No, I shouldn't zoom in. Okay. Here is the typical application circuit. So the input pins, obviously here, this input, you connect the input of your new module to here, input pin, the ground of your new module to the ground, of course, and the output of your new module. Usually there's no direct connection from the output to the IC. If there is, you can connect it there. But most of the case, the feedback is through a resistive divider, so you cannot connect the output there. Now, you can choose to connect to the output capacitor directly here. Like on the real circuit, you will connect it here, this point. But there's actually a better way to do it. You connect to the SW pin. You need to remove the chip so it does not interfere, of course. I will show you. The wiring is like this. Here's a coil and to the capacitor and to the out to your load. The inductor connects to the chip. Now you disconnect the chip and you connect your module. Your module inside will have a capacitor, and here connects to its own inductor. So basically this inductor capacitor forms a input filter that filters out even more noise. Of course, this inductor value is not tuned to do this job. It's tuned to be a switching power supply, of course, but at DC this have almost no effects, and any AC will get smoothed out somewhat. So it's beneficial to connect to the SW pin. And also it's easier to find. You don't need to, if the capacitor is all through hole, you don't need to solder it on the back or something. Just these 3 wires. It's very neat like this. Just 3 wires on the data sheets. Yeah, this in SW GND. That's it. And of course I've already tested, everything is working just fine. There's a bit of noise from the bug regulator, but everything else is okay. So yeah, I hope you like this video and this helped you, because you probably searched for this. If you like more tutorial videos like this, leave a comment to let me know, because almost no one watches them. So thanks for watching, bye.